Hi, we're here with Airwolf from Airwolf 3D. Eric, the last time we spoke, you had a pretty small little 3D printer, and we've got a little bit more serious unit here in front of us. Tell us a little bit about it.
Well, this is the Airwolf AW3D HD. It has a 12-inch by 8-inch by 12-inch build platform, so we can go 12 inches high with this. And it was really built in response to consumer demand. It seems that everybody wants a bigger and bigger printer. And so in addition to going larger in size, we also got a little higher precision by pulling the motor and accessories off the print head and putting them actually on the back of the printer. So we can minimize the moving weight. It helps increase precision and gives us the added benefit of going a little bit faster too. So one of the really cool things about this printer is it can be fully autonomous. This device down here is what's called a Vicky. And the Vicky takes a micro SD card right in here, and that card can hold 2 gigs or so worth of files. So it can literally hold weeks worth of printing on that card, and we don't need to plug it into a computer, which makes it really handy if you want to print in a room without computers, or you just don't want to have a potential USB failure from your computer, or your computer goes to sleep and shuts down the printer. This is actually how we run the machines at our office. We'll run 25 to 30 machines at a time, all with the micro SD cards, and we have virtually no print failures. We have very high quality, bearing quality rods, as a matter of fact, that support two-way motion. So we have the radial motion where the rod's turning, and then we also have linear motion where the head's going back and forth. So inside of these mounts right here are actually special Freelon bearings. And around those Freelon bearings, we actually have printed TPE washers to account for any misalignment. Funny story behind the TPE washers was that we knew we needed to put some O-rings around the bearings to account for misalignment, so we don't want the machine accidentally locking up. And it was actually quicker to print the TPE in the shop than go to the hardware store and buy the washers. So actually, the 2 little bearings in here are printed. There's 8 per machine, and every machine has them. So that's another kind of neat aspect. One of the neat features about this head is it's very lightweight. All we have is basically a hot end and a couple bearings and a fan on here. Most printers, actually, even the very expensive ones, tend to have motors up on the hot end. And when that happens, when the machine goes back and forth, it can actually flex the belts. And when it flexes the belts, you actually see a reverberation in the printed part if you look carefully, even on very high-end parts. So when you take the weight off the head, we can move it faster, we can move it more accurately because we don't have all that extra weight. So also we have the fan incorporated in the hot end for using connection with materials like PLA, soft PLA, and lay wood and lay brick. And that fan actually does 2 things. It'll cool the barrel of the hot end, and it will also cool the print as it's coming down. And we actually designed all these parts and printed all these parts with these machines, so we have internal passageways in the hot end to account for the cooling.
About how precise a feature can you do with this?
Well, theoretically, it I believe is 0.02 micron, 0.02 millimeters. In actuality, the extrusion hole is about 0.5 millimeter, so it's give and take a little. Most of any error would actually come from the plastic, not from the machine itself. One of the other really cool things about the machine is the belts. They're actually Kevlar, and rather than being sort of an off size like conventional printers, they have 2 millimeter spacing. So seeing as how most everything on these printers is done in millimeters, the 2 millimeter spacing gives you really great resolution. And in addition to those belts, we have actually twice the number of belts we would have in a normal machine, which just gives us more control over the print head and higher accuracy. We also have a really nice Z-axis on this machine. We have 12 millimeter rods, as you can see on the back on the sides. Extended linear bearings ride on those rods. And then controlling the up and down is a 12 millimeter lead screw. The precision on that lead screw is a human hair over the 300 millimeter travel, which gives you really incredible Z resolution.
About how fast can you build something with this?
Very quickly. If we just want to do a quick, rapid prototype is how we refer to it, maybe a few hours for 4 to 5 inch tall model. And it's good for getting a baseline. And then when you want to go smaller, we're going to go a little bit more precise in detail, we can do a longer print. We already kind of know what the object's going to look like. So the machine has room for 2 spools, and we've got a lot of questions. Does that mean 2 heads? And yes, we are coming out with the dual head, and that should be available in a couple months. And you can see on here, we've got 1 spool, and it's got what we call a printed spool miner to hold it so it doesn't accidentally uncoil. So it's a self-feeding system. It doesn't need any extra attention. That spool will stay on there for a couple days at a time to print out your parts if you need to. And on the other side, we just have the reverse of that printed part to hold another spool. And yes, you could run 2 different colors at the same time, and that's actually something we're working on right now.
There's quite a few 3D printers on the market. Where does this one kind of fit into the scale of things?
Well, this printer is on the higher end of the consumer market. It is just about the largest and fastest consumer level 3D printer you can buy. And so this is priced at $29.95. One of the really neat things besides the build volume about it is the materials it can process. It can print with up to 12 different types of materials, and that's a lot of fun. Soft PLA, flexible TPE, rubber-like material. People can really explore their imagination with this machine.
Can you give us an example of some of the things that have come out of these?
Let's see, we have some pretty large objects sitting on the table over there, and I can think of model cars we can do now with high precision. And actually across the booth from us, we've got a gentleman who built some very large robots with them. So we're seeing a lot of uses, not only consumers and the hobbyists, we're seeing a lot of professional companies using these for their daily prototyping needs.
So for small volume parts, could you actually do a production part with this?
That's a great question, and yes, we can. We sell on the order of 100 to 150 of these machines a month right now, and the machine actually builds itself. So each one of these machines will build another machine. And so in that fashion, they are doing small run production parts. So what we have here is a small football made with a material called TPE. And TPE is a lot like rubber and silicone. It's very flexible. One of the neat things about this material is that you can vary the infill on the inside of the object to vary the strength of the object. So for instance, if we wanted a little bit stronger football, we'd make this pattern a little bit tighter and put more material in there. And that's actually just a checkbox in the program. Right now, actually, we're printing out a bigger football. It's at the shop right now. It'll be here in a couple hours. And that football will actually be closer to probably 8 inches tall, and it'll be harder in the infill, so we're going to actually see how far we can throw it. But yeah, it's one of the neat things about this material is actually it has very good layer-to-layer adhesion. So compared with regular plastics, it's almost impossible to separate the layers. And then we've even got the lace marks on the front, so a lot of fun. This object right here, this would, I think, in the conventional world, be made out of cement or a type of material. A lot of people I know have these in their front yards. I think they're called foo dogs or stone lions. And if we can print it in regular ABS plastic, it would look nice, but a bit plasticky. This material is really cool. It's a cement-like material, and it's called lay brick. So if you feel the texture of it, it actually does feel like concrete or cement. And this is based on a PLA, so at least theoretically it's biodegradable. So we print it very much like PLA does. This print, for example, was about 10 hours long.
What kind of software do you need to run this printer, Eric?
Well, one of the neat things about the printer is it's based on open source electronics. So you can actually run the printer with a lot of open source programs like Repetier Host, Cura, you can use Slicer, and one of the other benefits with the printer is we have a company that we work with called Matter Hackers, and they produce a software called Matter Control. And it makes the machine really plug and play for your beginning user. Matter Control you can use with Mac and Windows, and basically you just plug the machine in, download the software, and you can be printing within 15 minutes.